Welcome back to Space Reviewed. I'm Andy. For our second review of this little series, we're going to be looking at this spacecraft, which you can see a model of in London's Science Museum. It's called Ariel 1, and it was the first British satellite. Named after the sprite in the Shakespeare play The Tempest, Ariel 1 was launched in 1962, making the UK only the third country to operate a satellite, after the USSR and the United States. Hooray for us! Except, it was really a joint effort with the US. And when I say it was a joint effort, I mean we absolutely could not have done it alone. NASA helped us design Ariel 1, and NASA built it for us, and it was launched on an American rocket from an American launch site. It turns out that picture of heavy reliance on the US isn't dissimilar from the situation for the UK today. We are dependent on the US for most types of satellite-based systems. High-end imaging satellites, and GPS, among other things. We do have some satellites of our own, although they're actually owned and operated by contractors on behalf of the UK Armed Forces, not by the government directly. But we couldn't have launched them without outside help, nor can we understand what's going on in space around them, or protect them from harm without using US systems. Luckily enough, this is actually kind of an opportunity, because we can now design an approach to satellites based on what we know today, while the US is stuck with their designs essentially based on 1960s and 70s technology. They can add to those systems, but they can't change what they already have. Back to Ariel 1. The Americans kindly launched it for us into space, past the Kármán line. But where in space? Here's the Earth and its gossamer-thin atmosphere. Satellite orbits are classified by their altitude, and the first category of orbital altitude above the Kármán line is called low Earth orbit, LEO. It stretches all the way up to 2,000 kilometers altitude, and it's where Ariel 1 ended up. You might notice that Ariel 1 looks like it's orbiting Earth off-center here, and that the orbit isn't quite a circle. That's not a mistake. The physics behind how orbits work means that they're actually always ellipses, a circle being a special case of an ellipse, like how a square is a special case of a rectangle. So Ariel 1 sat here in Leo, quietly getting on with some science experiments. Until this happened. This isn't a star shining through a Pacific sunset. It's a nuclear bomb going off in the middle of the night. The US wanted to know what would happen if a nuclear warhead was detonated in space, so 3 months after Ariel 1 was launched, they did just that. In a test called Starfish Prime, a 1.4 megaton bomb was set off at an altitude of 400 kilometers above the Pacific Ocean. Its effects surprised them. The pulse of electromagnetic energy caused blackouts in Hawaii and electronics failures in radio equipment. It was also a bit of a problem for other things in space, like satellites. To understand why, we need to talk about space weather. The Sun is a giant ongoing nuclear explosion. It's constantly sending out electromagnetic energy and charged particles in a stream called the solar wind, which is the most important part of space weather. Space weather also includes charged particles and energy coming from elsewhere in the universe. The solar wind would be very bad for us on Earth, but we're protected by Earth's magnetic field, which deflects most of it out of the way. But a little bit gets sort of trapped in the purple areas on this diagram, called the Van Allen belts. The radiation levels in these belts are much higher than elsewhere. If your spacecraft passes through them, it needs to be specially protected to avoid damage. The upper end of LEO normally overlaps a tiny bit with the bottom of the inner belt. But if you inject a whole load more energy, say by detonating a nuclear bomb, the belt expands downwards. Ariel 1 couldn't cope with that, and its electronics failed pretty quickly after the test. Nuclear explosions in space are a bit of an extreme scenario today, so perhaps we don't need to worry too much about man-made space weather. Although people do design satellites to protect against this, but even the most powerful nuclear bomb has nothing on the power of nature. This is a picture of the Sun, with the Sun itself blocked out so that you can see what's going on around it. It's from a NASA spacecraft that effectively sits in front of the Earth in its orbit around the Sun. This series of images covers about 24 hours, showing a huge eruption on the Sun, and then the degradation of the imaging sensor as the eruption hits the spacecraft. This eruption contained about 1 million times the energy of the Starfish Prime test. The last time something this big hit us on Earth, in 1859, it knocked out power lines and caused fires in telegraph stations. Had this one, in 2012, not missed Earth, it would probably have caused trillions of pounds of damage, and not just on Earth either. This spacecraft survived because it was designed to survive, but a lot of modern commercial satellites are designed to less stringent standards, and could well suffer the same fate as Ariel 1. So Ariel 1. It got us to space in 3rd place, which was pretty good, although we had to rely heavily on the US. Being named after a Shakespearean sprite also seems like a plus point to me, but it couldn't cope with the weather conditions, so I'm going to give Ariel 1 3 stars out of 5.